This chart has a lot of good information that allows us to compare graded potentials with action potentials in neurons. So let's take a look at each of these kinds of potentials in terms of a variety of characteristics. First, the origin. Graded potentials, you'll remember, arise mainly in dendrites and in the cell body. So whenever a neuron, for instance, is stimulated by a neurotransmitter, this is going to arise at the dendrites and in the cell body. But then that graded potential is going to travel down the length of the dendrites and then the cell body. And if at the site of the trigger zone or the axon hillock, the graded potential has maintained itself at a level of the threshold, then an action potential will arise and propagate along the axon. The types of channels that are involved in graded potentials are ligand-gated or mechanically gated ion channels. For instance, a neurotransmitter would generate a graded potential, or a mechanically gated ion channel is the type of ion channel that would be involved if a neuron was touched. On the other hand, action potentials involve voltage-gated channels for sodium and potassium. You'll remember that the sodium channels open first, and then the potassium channels open in order to generate an action potential. Graded potentials are decremental, that is, they will decrease in size the further and further away they are as they move away from the source of stimulation, and therefore they permit communication over short distances. Action potentials, on the other hand, propagate, that is, they do not decrease in size, and therefore they permit communication over longer distances along the axons. The size of graded potentials will vary depending upon the strength of the stimulus. On the other hand, action potentials are all or none. There's not different sizes of action potentials. Graded potentials are typically longer, ranging from several milliseconds to several minutes, whereas action potentials are shorter, ranging from a half to 2 milliseconds. Graded potentials may be hyperpolarizing, in which case this is inhibitory to the generation of an action potential because, of course, if it's hyperpolarizing, it's going to make it more difficult to reach the threshold level once that message gets down to the trigger zone. Or it can be depolarizing, which is excitatory. In other words, it's going to make it easier to get up to the threshold level. Action potentials always consist of depolarizing phase followed by a repolarizing phase and then returning back to the resting membrane potential. There is no refractory period for graded potentials, and thus summation can occur. We didn't deal with that in the previous sections, but we'll deal with that in a later section. With action potentials, there is a refractory period, and thus summation cannot occur.